All right, welcome to Module 5, Part 2. For this one, you're definitely going to want to grab your calculators to follow along. So we're going to be talking about data sets. That's a collection of values. You guys are going to be conducting a survey. You're going to end up with 30 data values. All right? So let's say you have a test scores. There's 75 kids in the class, and they can score between a 0 and a 25. These are the 75 scores, okay? So the data set itself comes from these scores. So again, maybe you'll have people's names here and you'll be collecting their numerical answers. So you're going to end up with 35, 30, this is 75. So you want to know how did you do, you want to know how the whole class did. So that's why we have statistical values so that we can compare answers and we can make decisions about the class. So the first type of thing to organize scores is called a frequency table. And so what that does is it actually collects all the data up by their frequency. So how many people scored a 1? One person, so these are people, scored a 1. One person scored a 6, 2 people scored a 7, 6 people scored an 8, 10 people scored a 9, and so on. So the frequency table really helps you organize so you're not looking at a list this big, but you're looking at a list that's a little more reasonable. So what can you do with a frequency table? That is an example of a data display. So you can actually take a frequency table and turn it into a bar graph. So you're listing out all the possible scores, and then you're using over here the frequency or the people. And then you're kind of saying, okay, one person scored a 1. And just by looking at this, you can see that this is the top score, the most frequent. And that means a 10. Most people scored a 10, but you can also see that most people scored between a 6 and a 16. You can see that we have 2 outliers. They're kind of outside of the norm. You can make all these decisions based on this data display. You can see the outliers, as I said, the people that kind of scored differently. Now, there's such a thing called a pictogram, and the only difference is that you would kind of assign a picture with instead of a bar. So in this case, it's easy to see that the red means that you're not happy, and these people are happy, and these people are medium. Now, you can be pretty misleading in a pictogram, and you can be misleading in a bar graph too. So let's take a peek here. So if we are looking at this, we see that it's showing between 2001 and 2006. And to me, it looks, like they really increased a lot. It looks low and then really high. But if you actually look, they started this scale at 50. What happens when you start the scale at 0? Does it look as big of an increase? Let's go back here. This looks like a pretty sharp increase, whereas this looks like it's more of a steady increase. So the fact is you really want to make sure, if you don't want to mislead, that you start at 0. Now you guys are going to be creating misleading surveys, so you might want to start at a misleading to really show something dramatic. So you always want to be careful at looking at the axes and how they're being labeled. So stretching, ways to mislead, a couple of tricks, would be to stretch the scale of the vertical axis or cheat by starting at the wrong number. So here you go. These are some examples of graphs here. We've got a pie chart, and we have some categorical frequency data. All right, mean, median, and percentile. So the mean is often called the average, but average can be a mean, median, or mode. So to find the mean, you add up all the data values and divide it by the number of numbers. So let's go back to our big 75 test scores. Now to find the mean, we would add up all these numbers and divide them by 75. That is like a lot of work. I mean, we can do it, but the frequency table can really help us here. This frequency is saying we've got 1. These are the scores we're going to be adding. We know we've got 1, 1. We've got 1, 6. We've got 2 7s. Now, we could have said 7 plus 7, right? Or 2 7s. We've got 6 8s, and so on. And we'll divide this whole thing by 75. So that's how you can find the mean from a frequency table. Okay, so let's take a look at this. The average starting salary of philosophy majors is $76,000 a year. Okay, that's a really high number. And so you might be like, oh wow, let's all go do that. But there happens to be a pretty big outlier who's in this mix. So if we were to take that one outlier out, we would have a more realistic view of the salaries. So the total of all 75 salaries is 75 times the salary. So again, if this is our average, we want to say, okay, 75 times that. So this is the total for 75 people, 3.5 million, that's like the majority of it. So if we were to take that 3.5 million out, we're really looking at this. And when we divide that up by the 74 remaining people, that's a more realistic average. So outliers can really affect the data. So let's take a look here. This is Billy's budget. When you just look at it, you can see that Billy has a lot of negatives, right? Check that out. He is mostly spending outside. So you would think his average spending would be in the negative. But when we calculate his mean, when we add them all up, and I encourage you to do that, you find out that it's a positive 26. Why is that? Right there. Because of these two big numbers, it really sways the middle value. So you want to be really careful with the mean. Percentiles are a way of comparing data. So if you score in the 60th percentile, it means if this was 0 to 100, if you score in the 60th percentile, that means 60% is below you. If you score in the 20th percentile, that means 20% is below you. So the median is our 50th percentile. It's right in the middle. It splits the data into half. Now to find the median, you have to sort your data first from smallest to largest, and then you eliminate at the same time the largest and the lowest. So what I mean by that is at the exact same time, you're going to take low and high, and that's one round. Low and high, and that's one round. Low and high, and that's one round. Now, if you're left with one number, let's say we had this. We did low, high, low, high. This would be our median, and we'd be done. But if we're left with two numbers, you're going to add them up and divide by 2, and your median will be the average of those two, the mean of those two. Now, a quartile divides the data even more. So if we have our 0 to 100%, and we know our median is the 50th percentile, quartiles sound like quarters. They divide it up into quarters. So we've got 25% and 75%. So this is our quartile 1. This is our median. This is our quartile 3. So how do you find the quartile? Well, first you have to find the median. So I'll show you here with our example from earlier. And so low, high, low, high. Oops, sorry about that. Let's add one more. And we end up with these two numbers, low, high, low, high. Okay, so that's the median. So our median here is going to be right in the middle, 3.5, and this is our median. Now, how you actually find the quartiles is if you have one median, do not include that value. So we're going to cut that out, and we're going to go this way and this way. If there are two medians, we're going to include them both. And then we find the median again. So I'm going to rewrite this so it's a little bit easier to see. So these are our two sections, and these are our two sections. So we find the median again, low, high, and the median here would be, this would be our quartile 1, low, high. This would be our quartile 3. And then here, that's all that's left. So our Q1 is 1, and here our Q3 is 3.5. And don't worry, we'll do another example of that as well. So we've got 11 homes sold in the last year. We're going to find the median and the quartile. So the first thing we do is we always take the data and we put it in order. I got rid of the zeros just for the moment for ease. So we've got median, low, high, That's 1. Low, high, pick up your pencil. Low, high, pick up your pencil. Low, high, low, high. So this right here is our median. When we have one value, we don't include it when finding the quartiles. So let's find our quartiles here. So that's low, high, low, high. So this right here is our Q1. Low, high, low, high. This right here is our Q3. So let's say someone just bought a house this morning, 264. So we need to add it in the right spot, making sure we keep it in the right location. And we want to make sure, oops, sorry about that, we want to put it in the right location so it stays in order, so it's got added right there. We're going to do it again. So median, low, high, pick up your pencil, low, high, low, high, low, high, low, high. Now we've got two values for our median, so we're going to add them together. So in my calculator, I'm going to do 252 plus 255, and I get 507. I'm going to divide that by 2, and I get 253.5 is my median. Now when we have two values, we use them both to calculate the quartiles. So low, high, and we end up here. So we're going to do 234 plus 238. Make sure you hit enter after that and then divide by 2. So our Q1 is 236. Low, high, so we get 264 plus 267. Divided by 2, we get 265.5 is our Q3. So when you have a frequency table, it's really important you pull the data table, the data values back out. So yes, it's going to be a lot, but the good news is it's already sorted. So you really want to make sure, okay, 1 1, 1 6, 2 7s, 6 8s, and you go on from there, and then find the medians and the quartile. The 5-number summary is just a way of calculating, putting all the data together. So you would give me the min, the Q1, the median, the Q3, and the max. So for that data set, for stats, that is the 5-number summary. To create a box and whisker plot, you're using the minimum, the Q1, the median, the Q3, and the maximum. And so you're just placing dots at the min and the max, and then a box around Q1 and Q3, and a line in the median. So let's create one real quick. So we've already done the data for this. So our minimum and max, our 5-number summary is right there. Our Q1 is 234. Our median is 252. And our Q3 is 267. So we create a line. This is really important. We want to make sure we're starting 220, 230, 240. We want to keep a good scale, 250, 260, 270, 280, 290, 300. We put a dot for the min and the max, a line for the Q1, 234, 252, 290, 267. Make a box and draw out the whiskers. And finally, in 15.3, we're going to talk about the range. We're not going to talk about standard deviation. The range is when we take the max and subtract the minimum. We can also get an interquartile range, which is where we take quartile 3 and subtract quartile 1. And that concludes Module 5, Part 2.